Core 4 partial fractions question here. So we start off by trying to express our 5 minus 8x in terms of our partial fractions. So I'm going to do this very, very quickly, and if you've got any problems with this, it's then looking back at partial fractions in a little bit more detail. So we can set up our equation for a and b, and then we're going to choose our x values. So our x values are going to be positive a third, because that's going to make that bracket 0, or the other x value is going to be minus 2. So if I'm putting positive a third in here, I'm getting 5 minus 8 thirds equals, this a bracket goes to 0, so no a's, and my b bracket, so plus b, 2 plus a third. Okay, now you've got calculators, we can very quickly do this on a calculator. So 5 minus 8 thirds is 7 thirds, and that is equal to 2 plus a third is also 7 thirds b. Okay, so that gives me the value that b is equal to 1. As I say, I don't want to spend too long on the partial fraction side of this. Substituting in minus 2 gives me 5 minus 8 lots of minus 2. So my that's going to be, plus, it's not going to be plus 8, it's going to be plus 16. Okay, which is 21. Putting minus 2 into my a term here gives me a 1, and then minus 3x times minus 2 is plus 6. And again, no b's. So I've got 21 equals 7a. So clearly a is going to equal 3. Okay, so go quickly, just scrolling back up to get to the final solution here. So I'm just using this one here. So a was 3, so I've got 3 over 2 plus x plus 1 over 1 minus 3x. So that's my solution, and that's worth 3 marks. So that is my part A sorted. Okay, now what we're then asked to do is to integrate what we were given in part A and show that it's a single value of some sort of rational number p times by ln 2. So what we're going to do is we're going to take what we've just done and we're going to integrate it between 0 and minus 1. So we'll just get ourselves a little bit more room here. So I'm integrating 3 over, let's just check what it is, 2 plus x plus 1 over 1 minus 3x, and we had 0 and minus 1. So the key thing for students here is to remember the integral of f dashed of x over f of x comes to ln. We have got modulus here. It really doesn't make any difference to what we do in core 4 or in core 3, in fact. So this is a standard result, one of the most important integration results that you can remember. So we can see that the denominator of this fraction here is going to differentiate to 1. We want 3. So our solution here is 3 lots of the natural logarithm of the bottom. And I'm going to use brackets here instead of absolute. It will make absolutely no difference. Good use of the word absolute. So that's our first one. The second one, a little bit more tricky, differentiates to minus 3. I don't want minus 3, I want plus 1. So I need to multiply it by minus a third. Minus 3 times minus a third gives me plus 1. So it's minus a third lots of the logarithm of the bottom. And that is the integration bit done. Okay, so it might be worth 4 marks, this question, but really there's a couple of marks just for knowing how to do these integrals. So now we're going to be substituting in our limits. So we need to take our time with this because, again, it's a show that question. So if it's show that, you've got to make sure that you are showing your examiner that you know what's going on. So I'm substituting in 0. So that's gone to 3 ln 2, and here I've got the third. Then now I put 0 in there, I get 1. So that's my first one, first limit in. Second limit in is minus 1. So I've got 3, 2 minus 1 is 1, minus the third, and I've now got ln. Now if I put minus 1 in here, I get 4. Okay, just double check you're happy with that. 1 minus the 3. So remember, you can use your calculator if you don't remember. Ln 1 is 0. Okay, so that gives us 3 ln 2 minus, well, sorry, let's just put that step in. So minus nothing minus a third ln 4. So then I've got minus a minus here, and minus here. So I'm going to rewrite this as 3 ln 2 plus a third ln 4. Now, remembering from the question, you can scroll back to the question if you need to, we're looking for it in that form, ln 2. And I've got a ln 4 here, so that's not ideal. So let's rewrite ln 4 as 2 squared. So 1 over 3 ln 2 squared. And you'll recall that there's a log law that says if I've got a power, that can be brought to the front. So I end up with 3 ln 2 plus 2/3 ln 2. And then if I've got 3 plus 2/3, that's going to be 9/3 if you like. Let's just write that we're using 9/3 plus 2 more thirds, 11/3 ln 2. And that's our correct answer, worth the remaining 4 marks, or the remaining 2 marks once we've got from there in this question. Right, we're now back to have a look at part B. The only thing I do want to make sure that we've got noted down, because it is going to be useful, was the answer to this one was 11/3 of ln 2. Okay, so just remember that we've just done that, but we're noting that down there. So we first of all want to show that this thing can be written like this. So this is actually an algebraic division question. So I'm going to use my box method for this. So what I'm trying to say is, what do I times minus 3x squared minus 5x plus 2 by to get the numerator? So let's just use some different colours here. So I want minus 6x squared. That's what I want for my numerator. So I've clearly had to multiply minus 3x squared by 2. And by doing that multiplication by 2, I would have also have done 2 times minus 5, which is minus 10x, and 2 times 2, which is 4. So I've got a bit of what I want, but I do have a remainder. Okay, so actually 2 is the answer. 2 is the value of C there, but we do need our remainder. So we're just going to check that that makes sense. So we've got minus 10x, we want minus 18x. So what do I need to do? I need to take away another 8x. I want, we've got 4, sorry, and I want 9. I need to add on 5. And then that remainder hasn't been divided. That's the important thing. That is still over the same denominator as before. Okay, and at some point in this question, we need to realise that that denominator is, so this thing here is the expansion of this one from part A. Okay, and once we've realised that, we can work out why this thing here is only worth 2 marks and it's not worth the 6 marks it's probably would be needed if we hadn't done part A. Okay, so what we've ended up with then is 2 plus 5 minus 8x, and I'm going to use the factorised form here. So C is 2, 1 mark, sorted. Got that there, just check the remainder. We're now being asked to find the exact region of the area bounded by this curve, so we're being asked to integrate. I'm being asked to integrate this thing, but I've just written it like this. So what I'm actually going to do is I'm going to integrate this one between 0 and minus 1. It's starting to look a little bit familiar because we've already integrated between 0 and minus 1. I'll use the highlighter just to draw your attention up here. We've already done most of this question. So what we're going to do is we're just going to take this, continue to use blue since I started in blue. So we're going to take this apart a little bit. Remember, if you've got two things multiplied together, that is the same as integrating them separately. And remember earlier on, I said we really needed to remember our answer from B part 2, because when I'm integrating, and so I'm losing my dx's here, very poor notation, is the answer to this was 11/3 ln 2. So before I do anything else, this is 11/3 ln 2. Done. I've done the integration, I've done the subbing in limits, that is a solution. Okay, I then just need, again, let's use the highlighter because we've got it, I then just need to do this bit. Okay, so to do this bit, integrating 2, nice and easy, is 2x minus 1 and 0, and I'm just going to now be substituting in these two limits. What we're going to end up with is putting 2 and 0 as our first limit and subtracting 2 lots of minus 1 from our second limit. Okay, and what we'll see here is that we end up with nothing minus 2. So that gives us positive 2 plus 11/3 ln 2, which we've got from the previous part. And that's my final answer for my 2 marks. So you can probably see now why this question was only worth 2 marks and not the 4 or 5 marks. It was probably actually worth doing if we hadn't already done all of our work from part A.